Hi everyone. So, it's not very often that you'll actually have a recorded lesson from me, but implicit differentiation is actually quite important and not many places have decent videos. So I'm going to actually go through this one with you. So firstly, I actually want to go at this starter first though. So pause the video here and have a go at differentiating those three things. You will need to think about all differentiation methods you've used up to now. Okay, so pause the video, have a go at those. I'll have a go through it in a minute. Okay, so those three questions for the starter. The answers are all there, so those are your three answers. I'm just going to talk about them for a second because you need to understand how to do them. So, this first one. You have a large function, so x squared minus 4, all within a square root. Now this square root makes it a bit more tricky to differentiate. If this was just y equals x squared minus 4, you would hopefully know how to differentiate it. However, this square root makes it a bit more complicated. So, think of how else you can rewrite a square root. Well, you can write it as a power of a half, can't you? Now, you can use a method called chain rule on this. Okay, now, I don't know how you've been taught it previously, but the way that I do it, imagine if the stuff inside of the brackets was just x. So imagine if it was just x, it would be x to the power of a half then. If you differentiate x to the power of a half, you bring down the power and reduce it by 1. So this differentiated would become, bring down the power, so a half x, then reduce the power by 1 minus a half. Okay, so if this was just x, we'd get a half x to the power of minus a half. So the same idea with this, differentiate this function we start with, bring down the power, keep the brackets the same, and reduce the power by 1. Okay, now we're almost there. However, this stuff inside of the bracket isn't just x. So to account for that, we multiply by the differential of the bracket. Now when I say the differential of the bracket, I mean literally just differentiate the bracket. X squared minus 4. X squared minus 4 is differentiated to become 2x. So our answer, a half times 2 is just 1. Put the x at the front, so x brackets x squared minus 4 to the power of minus a half. Now this minus just puts 1 over it, so the minus makes this x squared minus 4 go to the bottom, and the half is the same as a square root, so it's the same as x over the square root of x squared minus 4. So the answer. Now this one, as I've just said, is chain rule. It's chain rule because you have something within something else. They're connected. They're connected like a chain. This one, here we have two different functions multiplied together. Now when you've got a multiply, another word for multiply is product, isn't it? So here we want to use product rule. Now there is a formula for this, y equals uv. So if y equals uv, then dy by dx is u v dashed plus u dashed v. Okay, now again, I don't know how you've been taught this previously, however the way I think of it, I don't actually use the formula. What I do is, so dy by dx, I go straight to the answer. So look at your first function and differentiate it. E to the 2x differentiated, so if it's e to the something, you differentiate the power, so 2x differentiated is 2, and then the e to the 2x stays the same. So differentiate the first bit and then just multiply it by the second bit. Now we've differentiated the first, now we need to do the same with the second one. So stick a plus sign, differentiate the second bit. Sine of 2x differentiated is 2 cos of 2x. And now you multiply it by your non-differentiated part. And now that's your answer. Okay, so differentiate the one bit, multiply it by the non-differentiated bit, stick a plus sign, and then differentiate the other one and multiply it by the undifferentiated bit. Then this, we can factorise out 2e to the 2x in both of them, which leaves sine of 2x, cos of 2x, with the plus in between. Okay, now if you was to actually use the formula, you would just say u equals e to the 2x, v equals sine of 2x, and then you would find u dash, v dash, and sub them into the formula. Okay, this last one, now it's a division, isn't it? Like with product rule, multiply means product, division has another word for it, it's called a quotient. So this one, we use quotient rule. Now quotient rule, there is no nice way of doing it really, it's literally just you need to use the formula. Y equals u over v. So dy by dx, the formula for it is v u dash minus u v dash all over v squared. Now I'm using these u dash and v dash. Hopefully you know that u dash is the same as du by dx. If you didn't, then you're going to need to get to know that because it can appear in places. Okay, so u dashed is the same as du by dx. Now it is important which one you pick for which. So u is the top, so u equals x squared. V is the bottom, so v equals natural log of 4x. Now u dashed, differentiate x squared, you get 2x. V dashed, if you differentiate natural log of 4x, you get 1 over x. Another way of thinking of it is going to be 1 over 4x multiplied by its differential of the brackets. So you multiply by 4, so you get 1 over x. Now sub that all into your formula. So v u dashed, so v u dashed 2x natural log of 4x minus u v dashed, so u is x squared, v dashed is 1 over x, multiplies those together, you get x, then that's all over v squared, so natural log of 4x all squared. Okay, so there's your answer. Now, implicit differentiation, as I've said, this is a very, very important topic, and I'm going to tell you now, it's not exactly easy if you don't listen. Okay, and this is why I'm recording this, because if you was to read this, it wouldn't make sense. So, usually, you're used to differentiating things like y equals whatever. Okay, you're usually used to y equals whatever, and then you say dy by dx equals whatever that thing is differentiated. Okay, you're used to what's known as explicit differentiation, explicit functions. Okay, however, you need to know how to differentiate when it isn't in this form. Okay, so more like this. Okay, x squared plus y squared equals 8x. Here it's not y equals, so you need to be able to differentiate it straight away. And this is where this implicit differentiation comes in. Okay, now I've realised that I might be going a bit quick. The good thing about videos is you can slow it down or re-watch it or whatever, so if you need to, do that. Okay, so carrying on. Here, if we have y equals x squared, before you just think, oh, differentiate it, you get dy by dx equals 2x. Okay, now we don't just differentiate at the right hand side, we actually differentiate both sides. Okay, here we had y equals x squared, you usually just think, oh, it's y equals, so we just get dy by dx. In essence, yes, but we are actually differentiating y. Okay, y gets differentiated to give us dy by dx. Okay, so we differentiate both sides of the equal sign. Okay, so carrying on. This black box is the most important thing that you're going to see in this entire video. Okay, so if you're differentiating any function of y, so anything with y's in, if you're differentiating it with respect to x, then this is how you would do it. So if you differentiate some function of y, you just differentiate it normally, but then you multiply it by dy by dx afterwards. Okay, so if you differentiate something with a y in it, you just differentiate it as if it's normal, but then you just multiply by dy by dx. Okay, now you might understand that, you might not. It's easiest with examples, and that's why I've got loads of them. So here we're differentiating y squared with respect to x. Okay, differentiating y squared with respect to x. Now these are different letters, aren't they? So you need to think, oh, implicit differentiation. Okay, so as I've said, differentiate y squared normally. Now y squared differentiated is just 2y. Okay, hopefully you understand that. Y squared differentiated 2y. Because we're not differentiating with respect to y though, we're differentiating with respect to x, we need to multiply by dy by dx. Okay, so there's literally just one extra step. You differentiate the y squared, then you multiply by dy by dx. It's kind of like a correction. Okay, because you're not using the correct letter, you need to multiply by that letter over the one that you're actually after. Okay, now if you'd like to have a go at some of these before I actually go through them, pause the video, but I am just going to go through them now, so pause the video if you want to. So sine y differentiated with respect to x. Differentiate sine y as if it was just normal. So sine y differentiated is cos y. Because we're differentiating with respect to x instead of y, multiply by your correction. Okay, same again. E to the y differentiated with respect to x. Differentiate it normally, you get e to the y. Multiply it by dy by dx. Because you're not differentiating with respect to y, are you? You're differentiating with respect to x. So there's the three simple ones done. Now I'm going to go on to this one next. D by dx of xy. Now here we have two things multiplied together, don't we? However, neither of them are constants. So you need to use product rule. Okay, if we had x cos x, you'd just think product rule straight away, wouldn't you, hopefully? However here, because it's a different letter, you may hesitate, but it is still product rule. So like in the starter, differentiate the one thing and multiply it by the other non-differentiated. So x differentiated is 1, multiply it by the y, then put the plus sign in between, differentiate the y. So y differentiated, so we're differentiated with respect to x, so y differentiated is 1, but you need to multiply by dy by dx because it's the wrong letter. And now multiply by the undifferentiated other bit. Simplify this, we get y plus the 1 disappears, x dy by dx. And then there's your answer. Okay, so if you have two things multiplied together, you need to use product rule, and that includes if it's y's and x's. Now here, if you're differentiating e to the x squared y, now the power, it's not a nice power, is it? If you were to have just x in this power, e to the x differentiated is e to the x. Yeah? So if this was just x, the power, if you differentiate e to the x, you get e to the x. But because this power isn't just x, we need to multiply by the differential of the power. Okay, it's chain rule again. So we need to differentiate this power. So we've basically got a separate question in this. We need to differentiate x squared y. Now, it's very similar to this one, isn't it? This xy. It's a product rule. So differentiate x squared, you get 2x, multiply it by y. So differentiate the one, multiply it by the other. Then differentiate the other one. Y differentiated would be 1 multiplied by dy by dx. Yeah, y differentiated would be 1, but because it's not the right letter, implicit differentiation, multiplied by dy by dx, and then multiply it by the undifferentiated other bit. So this simplified 2xy plus x squared dy by dx. So going back to the original question, this differentiated would be e to the x squared y multiplied by the differential of the power, which is 2xy plus x squared dy by dx. Okay, so carrying on. Tan of x plus y. Now again, you've got a function within a function. X plus y is all in tan. So imagine if this was just x. Tan of x differentiated. Well, tan differentiated is sec squared. So this will become sec squared of x plus y. But because this isn't just x, we need to multiply by its differential. So the differential of x plus y, x differentiated is 1, y differentiated, so we're differentiating with respect to x, aren't we? So y differentiated is 1, but because it's not the right letter, multiply by dy by dx. So our simplified answer is 1 plus dy by dx multiplied by sec squared x plus y. Okay, and now the last one. If anything, this one's easier than a couple of the last ones. So x squared differentiated with respect to x is 2x. Cos y differentiated with respect to x. Now it's not the same letter, so it's implicit differentiation. So cos y, just differentiate it normally, you'd get minus sine y. But because the letters aren't the same, you need to multiply that by dy by dx. Okay? The dy by dx is separate, it's not inside the sign. Okay, so there's your answer for the last one. Okay, so implicit differentiation, it's relatively straightforward once you get your head around it. You differentiate it normally, but if the letter isn't the same, you multiply by dy by dx. Okay. So there's a neater written version. So, yeah, let's carry on. So those last questions, they were just single functions differentiated. The likelihood of you getting those in your exams isn't likely. You're more likely to get equations that you're going to differentiate. So, like these examples, find dy by dx in terms of x and y, where x cubed plus y cubed plus 3y equals 6. So, as I've said before, when you're differentiating an equation, you need to differentiate both sides of the equation. So let's differentiate this with respect to x. Okay, it's dy by dx. We're differentiating with respect to x. So differentiate this with respect to x. So x cubed differentiated is at 3x squared. Whoops. X differentiated is just 1. Now y cubed differentiated with respect to x. Differentiate it normally, but then multiply it by dy by dx. Okay, so that's 3y cubed done. And now 3y differentiated. Imagine if this was just normal. 3y differentiated is 3, but because it's not x, it's actually y. Multiply it by dy by dx. The equal sign stays in the same place. 6 differentiated is just 0, a constant. Now we're finding dy by dx, so we need to rearrange this to get dy by dx. So get all the dy by dx's on one side, everything else on the other. So here we're going to get all the dy by dx's on the left. So 3y squared dy by dx plus 3 dy by dx is equal to minus 3x squared minus 1. You can factorise out the dy by dx. And now divide both sides by this bracket. And there's your answer. Okay, find dy by dx in terms of x and y. There's dy by dx in terms of x and y. Okay, now next one. Find the value of dy by dx at the point 1, 1, where e to the 2x natural log of y equals x plus y minus 2. So we need to differentiate both sides of the equal sign. Left hand side, there's a product, isn't there? So we need to do these separately. So product rule. So looking at the left hand side, the left one, e to the 2x differentiated is 2e to the 2x. At this stage, hopefully you're good at chain rule. If you're not, you need to go back and revise it a bit. So e to the 2x differentiated is 2e to the 2x, multiplied by the other bit. Now product rule, we've done the differentiating of the one bit, we need to do the opposite. So natural log of y differentiated. Now it's not the right letter, is it? We're differentiating with respect to x, so we need to use implicit differentiation. However, imagine if it was just x. Natural log of x differentiated is 1 over x. Yeah, natural log differentiated is 1 over. But because this isn't x, it's actually y, we need to times it by our correction. Okay? So we've differentiated natural log of y, but because we're doing product rule overall, we need to multiply by the undifferentiated other bit. Now that's equal to just this right hand side differentiated. X differentiated is 1, y differentiated is 1 times by dy by dx. Y differentiated is just 1, but because it's not the right letter, you multiply by dy by dx, then the minus 2 disappears. Okay, and now get all the dy by dx's on the one side, everything else on the other. So 1 over y dy by dx e to the 2x minus dy by dx. So I'm bringing the dy by dx to the left, and I'm going to bring this 2e to the 2x natural log of y to the right hand side. Factorise out the dy by dx. I'm factorising, so I need to bring that out. 1 over y e to the 2x minus 1 equals 1 minus 2 e to the 2x natural log of y. So dy by dx equals the right hand side all over 1 over y e to the 2x minus 1. We're evaluating at 1, 1. So dy by dx at that point, substitute those values in, so it's 1 minus 2e to the 2 natural log of 1 all over 1 e to the 2 minus 1. Natural log of 1 is 0, so this is just 1 over e squared minus 1. Okay? And there's a nicer looking answer. Okay? So hopefully you understand this so far. What I'd like you to do is have a go at these two questions. Okay, there's two exam questions for you to have a go at. So pause the video here, please. Have a go at those two questions. I'll show you the answers in a second. I'm not going to go through them. I'm just going to show you the answers. So they're exam questions. Have a go, pause the video, and I'll show you in a second. Okay, so answers are there. The left-hand question was the one on the top before. The right-hand question was the one on the bottom. Okay, and it's like a proper mark scheme. So your answers should have been here and these. And then here your answer is this thing in the curly brackets, and then y equals 7/3 and 5. Now on Google Classroom there's the worksheet 9H. There are certain questions that I'd like you to do. So the questions that I'd like you to do, I'm looking in the wrong textbook. So I'm not going to give you many because this lesson's already been long already. Let's just go with questions 6, 8, 10 and 11. Okay, so have a go at those. I also have put the solutions on Google Classroom, so check your work afterwards. You can try more than those questions if you'd like, but that would just be for practice. I don't really need you to do them. Okay, so have a good rest of your day. I'm going to pause this video here, and yeah, see you soon.